of real business problems with Scala, and hopefully for those of you who are kind of newer to the language, which I see there's quite a few tonight, it'll give you some food for thought in terms of good use cases where you can apply some of the fundamentals. I wanted to start off though with a little bit of trivia. Can anyone tell me what the Apple II and then a famous 2 billion trading loss at JP Morgan had in common? Yeah. So the thing is, it's the Spreadsheet, which was the portable computer's first killer app. It was responsible for a lot of sales of the Apple II. Businesses suddenly realised that here was, a useful thing that they could actually run on these boxes. And then obviously in JP Morgan's case, they kind of abused the spreadsheets, and it didn't really work out too well in their favour. And then here we have a bit more about that, where basically there was a very manual process, and this model consisted of data being copied from sheet to sheet, and as you'd expect, there's quite a lot of room for error there. So I'm going to give, as you can see, a quick bit of background about the spreadsheet, because it's kind of interesting as well that it's it's been around since 1979, which is older than, well, some of us anyway, and it's kind of not changed fundamentally that much over the time, but it wasn't until it was 6 years old that Excel came along, initially on the Apple, and then over the years there's been other competitors that have come and gone, been swallowed up, and then I guess more recently the sort of shift into the cloud-based offering. But nowadays, you've still got Microsoft Excel at the center of that. You've got OpenOffice, you've got Numbers, you've got some cloud-based offerings, but it's still everywhere in businesses. And the reason it seems to end up in that situation is I'm sure some of these use cases a lot of you can relate to. So the actual ones it's intended for, like your accounting, inventory, simple reporting. But then you've got the more exotic use cases as well, where people start doing complex risk management on that, and capturing transactions and all these things that start off pretty innocent, but over a period of time, it's just not a very sensible way to go. We end up in this situation again and again because typically people, it might be they're coming from a technical background, but all they know is Excel, so they write a load of VBA code, and for us developers anyway, it's not always the best choice of language, but obviously people have got to work with what they know. But fundamentally, you don't have that upfront sort of thought about where the application is going to go and so on. And over a period of years, these things become business critical, and then it might be that you have a big trading loss. It might be that audit comes in, or management. Someone comes along and says we've got to move off these spreadsheets, and a proper solution needs to be built. So these complex spreadsheets, I say there's a few things that that they have in them that really contribute to why they're not very practical. They've got you almost have mini databases inside some of them, where you'll just have multiple reference tables. There's very complex calculations. You can't really debug them other than breaking them down manually into their separate stages. And obviously unit testing just does not exist in the world of Excel. And then obviously lack of centralization too, but they're often on a file share if you're lucky, or more often than not, they live on someone's PC somewhere. So as Dilbert illustrates here, the spreadsheets, they're not a good thing. So what can we do around the automation of them? I'm going to talk about a few different technologies. The first of these is the Apache POI project. This is basically a library that enables you to interact directly with Microsoft documents without actually having to be on Windows as well, which some people may see as a nice thing. But the point is that you can create or modify or do whatever you want with these documents from Java code or Scala code, which obviously helps here. Then we've got Scala. There's a lot of fans of it here for obvious reasons, but the key things which are quite useful when you first learn about it, the streams, for comprehensions, and case classes. And also, not all organizations have made the move yet to Java 8, so for environments where it might be a while off, or for whatever reason, it's nice that you can kind of just pull it in and get working with it. So with the streams, the simplest way to think of them is where you've got, say, some tabular data here, where you want to perform some sort of aggregation on the data, like calculate the average, and then from that average you want to calculate the difference each of these prices were from the actual average. So with Excel, obviously, you can see how it would be done there with some formulas in the background. But if you were to do this in sort of Java code, you'd have sort of a for loop there. And, well, sorry, before Java 8, you'd have had a for loop there to do this. But using Scala, you've just got a nice sort of concise notation where you've got your prices there as a list. Then you can just do a sum, which basically aggregates across all of the elements in the list, which you get that for free, and then you can calculate your average, and then you can apply a function to actually calculate your deviation from the averages there. The other piece is for comprehensions, and especially when people are first sort of getting used to the syntax of Scala, and also functional programming. Working with maps is fairly intuitive. Flat maps a bit less intuitive, and where you end up in this sort of situation where you've got, in effect, a couple of different streams that you want to do some processing on. For comprehensions can simplify that a lot, because conceptually, for those people coming from an imperative background, you can just have sort of your outer, your inner variables, apply some predicates, and then you can produce a pair. But if you're doing that using, I guess, a more traditional functional approach, you end up using sort of flat maps and then maps and filters within there, which is for newbies anyway, it's not very intuitive when you're starting out with this stuff. And so that's a very nice feature of the language as well. And then finally, you have your case classes too, which instead of having to write all the usual sort of boilerplate code that you get with your Java beans and whatever else, it just provides a nice straightforward way to do that, and you get your equals, hash codes, toStrings, and all these other sort of fundamentals things there for free. The other piece is BDD, and within Scala, there's, I guess, two main frameworks here. We've got Scala Test and Specs 2. Probably against Eric, who maintains Specs 2, who's sitting in the front row. I'm actually going to be talking about Scala Test here, but just to give us a slightly broader perspective of the two different languages, it's two different frameworks, but I'm sure he's got a host of reasons as to the advantages it offers. So just to sort of give you a little bit more context, I thought let's use an example for this rather than just talk in terms of the code. So say someone's designed a model where they want to see if there's a correlation between the prices of bitcoins and commodity returns. This talk was originally for Yao West, and there's obviously a lot of people into their commodities in Western Australia, so I thought it was quite an apt combination of things to have there. For sourcing this sort of data, and this is slightly off topic for the usual talk, but it's nonetheless a fantastic website if none of you have come across it, Quandl. They have data for all sorts of price and asset type data, if that's the sort of stuff you're actually interested in. And if you want to do anything with data or prices, I really recommend you check it out. They've got a great RESTful API that you can use to easily pull down and source data. But in this example, our less tech-savvy person decided to pull the data down and put it into a spreadsheet. So the model itself, it's fairly straightforward. There's, as with all these things, there's like a bit of munging that needs to happen at the start. So data needs to be reordered, then they create some named ranges as well, just to kind of label the data in the sheets, and then perform a few calculations, just fairly vanilla ones. So just the returns of the different prices, the mean, the standard deviation, and then the covariance, which is kind of a key thing for calculating correlations. It's basically just the it's how much two different series vary from one another, as opposed to it just being varying from a single mean. So there's some data. So we've got some different prices there for, this is our AUD Bitcoin. Then we've got the ASX commodity returns. ASX commodity futures. And then we've got our spreadsheet there where we've got these calculations that happen at the end. So that was the model that someone had built. And yeah, here's just a bit more detail on that. I'll just keep going through. Sorry. Yeah, and the end result, though, is that there isn't a correlation there. But, the point is someone built a model to try this, and, maybe in time there will become one. So they thought, we need to keep this spreadsheet and make it production-like. Yeah, so we've broken it down just into a few different Scala classes here. We've got an Excel reader, which basically wraps the POI library. We've created a very simple stats library. And again, I think the talk after this is probably going to show you a much more sophisticated way of solving this problem. And then also we just have our sort of correlation bit here. So here's our Excel reader, just a sample of it. When I wrote all of this stuff, I put it all up on GitHub. So there's code there if you do want to sort of take a look, and the Excel stuff's there as well, and everything else. But the point is that for people coming from the Java background, instead of we've got this sort of closure here, so. Which handles, well, which captures, if any exceptions or anything else that can be thrown there, but ultimately it extracts the sheet into we've got this result set which kind of encapsulates what's in the spreadsheet, but we've just got it, we've just created an object to wrap it there, and then we've got our stats library. And again, I think when you're working with some math formulas and so on, it's a very nice thing in Scala just how clear this stuff can be. So because of its more flexible syntax and just being a more concise language, you can look at things like the the correlation at the bottom here. And although I don't have the original math formula there, you can kind of see that the correlation is the covariance of two different series there, divided by the standard deviation of one times the standard deviation of the other. And it's just nice that it gives you that sort of very readable stuff, and it's not that dissimilar from what the actual mathematical formulas would look like. And then finally this is just some code just to run the whole thing, which there's not really too much to say there, except it produces a number at the end. So finally, the end-to-end validation, and this was another sort of key area here, because people like your boss, if you were lucky enough to have someone like Bill Lumberg, could potentially actually make sense of what some of your tests are doing, and that's a very, very powerful thing, because even as straightforward as unit tests are. In Java, you can, and you do have good BDD frameworks and so on. The ease with which you can write tests in Scala that are very legible to your BAs or whoever else, or you can output the result from your tests and integration, well, your test cycles in a format that is very readable for the average person who doesn't actually understand what the code's doing. So here we have our tests, and again, it's reading through it. It's all pretty straightforward there. We're just checking that the means and everything else are calculated correctly. But what we're doing is we're actually validating these against the spreadsheet values. So we've got POI plugged in behind the scenes, and then that's just this is pulling the data out of the sheet to validate that our calculations are actually identical. So in terms of the they're double values, and we get an exact match between the doubles there. We're not having to sort of look at we're not having to look at any sort of precision or so on. We're just getting spot on there. So that's a nice thing there. And with that, you get the very sort of clear test output, which I mentioned earlier is something that is very valuable for less technically minded people. So this just gives you, an idea of the foundations for building, I guess, MVPs and so on. You'd never, ever, ever want to have something, running in a real life system that was hooked into a spreadsheet. But at the same time, when you want to get something out the door quickly and so on, these sorts of tools are very useful because you don't have to go off and, design your storage and all this sort of stuff in order to do it. And it's obviously open to abuse as well, and all sorts of acronyms like micro spreadsheet services or whatever else you want. There are some limitations as well. It doesn't support VBA. I can't imagine anyone's ever going to try and put a VBA interpreter in Scala or Java or anything. But you also find the odd functions in Excel. They're not actually supported, but then it's an easy way to contribute back to an open source project as well, because it's not too difficult to write implementations of them. And so, as I said, there's it's an interesting selection of tools if you want to have a play with this sort of stuff. And also, I think it kind of demonstrates a lot of people really understand the sort of spreadsheet abstraction when they think about data and so on. That's why it's been so successful over the years, and it isn't going to go anywhere anytime soon. But then, seeing how that does translate itself very nicely to more functional techniques such as mentioned here. Hopefully will give you a bit of an insight into why it is so popular in areas such as data processing and so on. That's all I had to say. There's a few further resources there. And like I said, I put stuff up on GitHub back when I wrote this originally, and just a bit of background there too as well, if anyone wants to take a look. Are there any questions? Good.
Thanks.
Thanks.